equations, we got to know how to do these properties. So I'm going to give you a few properties today, and hopefully maybe they're vaguely familiar to you, and then we're going to use these to help us solve equations, which is the next section, okay? So we're going to start with a very basic property called the change of base formula, and I'm going to give you this formula 3 different ways, because you can actually do this formula 3 different ways. Second, I would say I was doing these notes, and then it just stopped working like it normally stops working in here. And I checked all the chords, and then the whole thing just shut down. And so then we had to turn around and learn on the chalkboard. It's very old-fashioned, non-technology notes today. But hopefully today, this one won't shut down. Change of base formula allows you to change any logarithm of any base to any other base that you want. So I'm giving you the very generic definition right now. If you have log base a of x, you can rewrite that as any base that you want, as long as you put whatever the base is originally on the bottom, and this number goes on the top. And you can change it to any base that you want. And so let's say you had log base 7, and you wanted to change it to log base 9, you can, as long as you put the things in the right order. But log base 7 to log base 9, why would you do that? Because neither one of those you can use on your calculator. And so I'm going to give you both of these formulas with the 2 buttons that we have on our calculator. The first one is base 10. Remember that one we call our common logarithm, because we're base 10. We like base 10. There's a button on our calculator for base 10. And if you want to change a log base 7 that you can't do on your calculator to log base 10 that you can, all you got to do is remember that the base goes on the bottom. So this will become log base 10 of a. I'm not writing the 10 there, because remember we don't have to. And the x goes on the top. So log base 10 of x. And that will give you the answer. And so now you have a way of doing ones that you couldn't do on your calculator before with your calculator, which is why we have a no calculator part of the test. The other one we like to do is base e. Remember that base e is the natural logarithm, that's ln. It's the same formula, but instead of changing it to base 10 or base b, we're just going to change it to ln. But remember, here's how I remember the formula. The base goes on the bottom because they both start with b. So the a part goes on the bottom, and the x part goes on the top. So I would take ln of x over ln of a, type it in my calculator, and I get an answer. You got to know this formula by the time we have a test. And every time there are people that switch it around and get the wrong answer. So base goes on the bottom is your key words there. So it says rewrite as log base 10 and then evaluate to 3 decimal places. There's questions like this on your test. Really important that you read the directions of what it's saying. You're doing 2 things. First, I want you to rewrite it using the formula. I want to see that you know the formula. And then you're going to use your calculator to evaluate it. And it's really important that you're typing it in your calculator a specific way, because otherwise you're going to get the wrong answer. Why is this formula so nice? Could you do this without a calculator? Like, could I have given you this on your worksheet on Friday? This is like saying 5 to the what power equals 89. Do you know that? No. I know 5 squared is 25. I know 5 to the third is 125. So it's somewhere in between 2 and 3. But I don't know the answer. But using change of base formula, we can get the really close answer here. So remember, the base goes on the bottom. So I'm just going to rewrite this as log base 10 of 89 over log base 10 of 5. And then you're going to type this in your calculator. Who needs a calculator? Really important that you type this in correctly. On my calculators, when you hit log, parenthesis there. If you do not close that parenthesis, your calculator is going to take a log of everything you type in after that parenthesis starts. And so it's really, really important that you practice doing this. I cannot stress enough that there are questions on your test where you have to use a calculator, and if you type it in wrong and you get the wrong answer, you're going to miss that point, which is why I'm doing these in class with you. But you got to make sure that you close that parenthesis. The bottom one, I think it's a good habit to get in the habit of closing the parentheses when it's open. But if you don't close the bottom parenthesis on the 5, not a big deal, because you're not typing anything after it but the 5. But if you don't close it on the top, you get the wrong answer. But I'm just going to type log of 89 divided by log of 5. And I believe we get an answer to 3 decimal places of about 2.789. If you didn't get 2.789, then that means you typed something in your calculator wrong. I would recommend, if you have a calculator that you know I'm not going to let you use on the test, you start practicing with my calculators, because this is the calculator or a type of calculator that you're going to be using on the test. You're not going to use a calculator where you can just type in log 5 of 89. If your calculator does that, you'll not be using that calculator on the test. You can check this. This is the exponent. If you take 5 to the 2.789, guess what? It's going to equal almost 89. Not exactly, because we cut off the decimals, but about that. So, probably not. I don't know. I'll have to check that. There's something like this that is called natural distance. Yours doesn't say natural distance. You might hear it. Right. Do this one. I threw this one in because it adds in another set of parentheses when you're typing it in your calculator. This is saying the square root of 2 to what power equals the square root of 5. Definitely wouldn't want to do this without a calculator. The formula part, I hope, isn't that bad. The base goes on the bottom, so log square root of 2 on the bottom, log square root of 5 on the top. But again, I just want you to start practicing with your calculators here. When you type log, at least on my calculator, it puts a parenthesis. When you type square root, it puts another parenthesis. And so you've got to start remembering, when do I close those parentheses? Well, we just want the square root of 5, so we have to close that parenthesis. But we also want it to stop taking the log at that point, which means you have to close that other parenthesis. So on this one, you actually have 2 parentheses on top, that if you don't close both of those parentheses, you don't get the right answer. And so calculators are really great, but you got to make sure you know how to use them. Again, on the bottom, it's going to be the same thing, but if you don't close the bottom parentheses, not as big a deal because there's nothing after it. But the top one, it is a big deal. 5 divided by log of square root of 2. And I think I got an answer of 2.322. Do you agree with that? Again, it's just knowing the formula, but making sure you're typing it in correctly. Questions about that? You can do the same thing with ln. We actually could do these same problems, only changing it to ln of 89 over ln of 5. You get the same exact answer, but just make sure you read the directions on which one they want you to use. Like this one says rewrite as log base 10, as opposed to if the directions say use natural log to evaluate, that means I want you to use ln, right? Natural log is the ln function. But know that log base 10 base of change of base formula and this change of base formula, it gives you the same answer. It just asks you, it just tells you which one to do in the problem. But the formula is still, the base goes on the bottom. The only difference now is we're using ln. So I would get ln of 18 divided by ln of 5. And when you divide that out, you're going to get your answer again. Again, ln automatically puts a parenthesis, so you have to make sure that you close that parenthesis. I'm going to go to 3 decimals again, so I'm going to get 1.796, I think. Good with that? Same thing with this one. I threw in some different numbers here. Log base pi of e. I like to throw e in here when we're using ln because we actually could simplify it a little bit, or we could just type it on our calculator. But the base goes on the bottom, so that means I would get ln of e over ln of pi. What is ln of e? So it gives you what? 1. So if you wanted to, a little less stuff to type in your calculator, that's the same as 1 over ln of pi. Remember that ln and e are inverses, so it's really nice if you can simplify that. But you can just type ln of e on your calculator. If I'm letting you use a calculator, be aware that my calculators, most calculators, when you type e, it automatically asks you what exponent. So in this case, e would be to the exponent of 1. But I'm just going to do 1 divided by ln of pi. And I got 0.874 if I'm going to 3 decimal places. Yes? Change of base formula. Not a big deal, but it comes up. It's very useful at times. The other formulas we're going to use today are the ones that are really important as we're solving equations. And so that's what the main focus of your homework is. So let's just write these out and then we'll practice a few. Oh, so you have to leave. That's not good. These properties come from exponent rules because remember that a logarithm is an exponent. And so if you know your properties of exponents, these kind of make sense. If you're multiplying two exponents, like x squared times x to the third, what do you do with those exponents? You add them. Multiplication, you add the exponents. It's the same thing with logarithms. If you have the logarithm of something multiplied together, you can actually separate that into addition. Like this is the same as log base a of u plus log base a of v. And usually when we're solving equations, it's more useful to go from this way to this way, and we'll talk about that as we get to that. But if you see addition, you can put it back together as multiplication. If you see log of multiplication, you can break it apart as addition. I gave them to you in ln also, but remember that ln is just logarithm, so this is the same thing. This is the same as ln of u plus ln of v. So you got to remember, multiplication breaks up into addition. Remember doing this last year? No recollection. So we also have a property for division. When you divide with exponents, what do? You subtract them. And so when you have a logarithm that's division, you can break it up as subtraction. And it comes from the fact that when you divide exponents of the same base, that you subtract them. And so log base anything of u over b, we can rewrite that as log base a of u minus log base a of v. So multiplication goes to addition, division goes to subtraction. I could write this as ln of u minus ln of v. And then the last one I think is the one that's the most important when we go to solve equations is dealing with exponents in a logarithm. This one comes from the fact of when you have an exponent next to an exponent. So if you have like x squared to the third power, you multiply those exponents. So that means if you have a logarithm raised to an exponent, you can actually pull that exponent in front and make it a multiplication problem. So anytime you see something with an exponent, this can go out front, and that's the same as saying n times log base a of u. So think back to those exponential equations. When you have an x up in an exponent, How can you get an x out of the exponent spot? Well, if it's a logarithm, you can just pull it out front, and that's where it comes in very handy. Same thing with this. I can bring this out front and say n times ln of u. So the majority of your homework is going to be practicing either breaking up logarithms or putting logarithms back together using these properties. So I just have a few examples of these, and then we're good. Can I go? So we're going to start with some actual number ones, and then we'll get into the ones with letters. Every pre-calculus book I've ever taught out of likes to start with this with properties because they like to see if you know the properties, and then they actually throw the variables in there. But it says rewrite each problem in terms of ln of 2 and ln of 3, which means your answer can only have ln of 2's and ln's of 3's, or some combination of those. So when you see ln of 8, you have to think about, can I rewrite 8 using 2 and or 3? Maybe we should do the 6th one first. I feel like that one's easier. Let's do this one first. Can I rewrite 6 using 2 and or 3? How can I put 2 and 3 together to get 6? I can multiply them, yes? So could I rewrite this and say ln of 6 is the same as ln of 2 times 3? Is that the same as ln of 6? And then the property says, what can we do with multiplication? We can break that up into addition. So this is the same as saying ln of 2 plus ln of 3. And on your calculators, you don't have to do this, but if you took the ln of 6 and you wrote down the decimal, and then you took ln of 2 plus ln of 3, it really does equal the same thing. Is that very applicable to real-life problems? No. But it's kind of making you think about those properties, which is why they like to start with those. Make sure you close your parentheses when you type ln of 2 when you're doing that. Same thing with ln of 8. What about 8? How can I rewrite 8 using 2 and or 3? Yeah, 2 to the third, right? So I'm really not actually going to use 3 on this one, except for this is the same as ln of 2 to the third power. And then what can I do with that exponent? Take it to the front, and so this one would be 3 times ln of 2. And again, that is going to give you the same answer as ln of 8. So it's just kind of practicing using those formulas. I think there's a multiple choice one on your homework today that asks you, like, which one of these would be the same as, like, ln of 12, and you just have to think about the properties of what they would make to multiply to give you 12 or divide to give you 12. Okay? Yes. Right. Another way of writing this would be ln of 2 times 2 times 2, which you could break into ln of 2 plus ln of 2 plus ln of 2, right? And then if you have 3 of those, you still get back the same thing, so it would be the exact same thing, just whichever way you think of it. Okay, here's the real focus. Most of your homework is going to be focused on stuff with variables, and when it says expand each logarithm, that means break it up using those properties. If you see multiplication, break it up to addition. If you see division, break it up to subtraction. If you see exponents, bring them out front. Like everything that you can break apart, we want to break apart. And then see if you can simplify it, because that's where sometimes log 3 of x over 9 I can't do anything with, because I don't know what x is. But if you break it up, sometimes you can simplify something. So what can I do with division? Subtraction. And so I'm going to rewrite this as log 3 of x minus log 3 of 9, because that's the property. You with me on that? And then I just want to caution you, once you break it up, see if you could simplify anything. Log 3 of x, can I do anything with that? I don't know what x is. What about log 3 of 9? Yeah, isn't that saying 3 to the what power equals 9? So if it's one of those that works out to be a nice number, I don't expect you to give me crazy decimals. So log 3 of 9, what does that equal? 2. 2. So this would be the answer that I would be looking for there. Log 3 of x minus 2. So try number 8 here. See if you can break that up and see if you can simplify it. What's the first step? What can you break multiplication up to? Addition. And then can you do anything else? Tyler? Yeah, we have a couple options here. One option is we could bring that x out front because it's an exponent. And what does ln of e equal? 1. So we actually would just end up with 1x. Someone in second hour today remembered that there was a property I gave you that ln of e to the anything just gives you x back, so you could get that as well. Either way you do it, you should end up with just an x there because ln of e is just 1. Remember, ln of e always cancels each other out. So I think you would get ln of x plus x on that one. You're not going to always be able to simplify it, but I gave you a couple that you could just to show you. Okay, ready for the hard one? I didn't wait for your answer. In case you said no. Log base 5 of the cube root of x squared plus 1 divided by x squared minus 1. What do you see that we could do right away, forgetting about how awful it looks? Yeah, division, I see division, that means I could do subtraction. So I could say log base 5 of the cube root of x squared plus 1 minus log base 5 of x squared minus 1. I want to caution you, notice I put this in parentheses. I think it's really important that when you have something added or subtracted in a logarithm, that you put it in parentheses, because look at this one and this one. You see how it'd be really easy if I didn't put parentheses around this? How would you know the difference? Like, how do I know this is an x minus 2? You see what I'm saying? So I just want to caution you that it's a good idea that when you have something added or subtracted that you put parentheses around it if it's all in the logarithm. Think about how you would write it in your calculator. You wouldn't close that parenthesis till after the 1. What else can I do? I'm kind of doing a bunch of stuff here. How about this cube root? Could I rewrite a cube root in another way? We talked about this on Friday. Yeah, I'm going to kind of show my work here, but isn't the cube root of x squared plus 1 the same as x squared plus 1 to the 1/3? And why would I want to do that? Well, because I have a lovely property that says if I have an exponent, I can bring it out front. So anytime you can make an exponent, like anytime you have a root like that, if you can make it an exponent, well, then I can just bring that out front, and that looks a whole lot better. Now I have 1/3 times log base 5 of x squared plus 1. Again, notice I put it in parentheses. That's really not terrible. I just want to throw it in there because it might show up. Here's the terrible part. That if we didn't do this, I wouldn't expect that you would know how to do this. But it does show up every now and again. Forgetting about the log for a minute, if you were trying to simplify x squared minus 1, is there anything you can do to x squared minus 1? Yeah, can I factor this? Is that a difference of 2 squares? Why would maybe I want to factor this? I can factor this into x minus 1 and x plus 1. I can't factor x squared plus 1 because that's adding. Can't break that up. There's nothing that multiplies to give you 1, that adds to give you 0. But I can break up the difference of 2 squares. And here's why that's an important thing. I can't break up addition and subtraction in a logarithm, but if I factor it, I've now turned it into a product. Do you agree with that? It's now multiplying. And can I break up multiplying in a logarithm? Yes. And so every now and again, they throw in this little factoring one that throws people off a little bit, so I like to do it. So I could actually break this up, but I'm going to actually show a little in-between step here. Don't forget there's a minus in front of this, so I'm going to kind of put a parenthesis around that, because I'm subtracting the whole thing. I could break log base 5 of x minus 1 plus log base 5 of x plus 1, because multiplication goes to addition. And the last thing I want to throw in here to talk about in this one giant problem is that when you are subtracting two things, you got to remember that you're subtracting everything here. So one thing is you could just leave your answer like this. Because I put a parenthesis out here, yeah, I closed it back here, that means I'm subtracting all of this, and so I wouldn't mark that wrong. But if you didn't put that extra parenthesis in front, it looks like you're only subtracting this, which means I'm only dividing this, and I'm multiplying by this. I'm not dividing. And so it's really important that you do this. The book subtracts both of them. So this is how the book writes the answer on this one. 1/3 log base 5 of x squared plus 1 minus log base 5 of x minus 1 minus log base 5 of x plus 1. And when I see this, because I've done it a lot, when I see two subtraction signs right in a row, I know that means, oh, I'm dividing by two things on the bottom. And so that's something that you kind of get used to seeing. But either one of these would be like the simplified answer. Are they all like this? No, but I want to show it to you.
Couldn't you bring up like the first part of the equation where it says 1/3 log base 5 x squared plus 1? Break up x squared plus 1.
Into factoring?
Yeah.
You can't because it's adding. Like what could you break? Like there's nothing that factors into because it's plus. Because it's not like when you have a minus here, you can make them different signs. But when it's a plus, they either have to both be positive or both be negative, and then you wouldn't get 0 in the middle. Here's the other part of your homework. They're going to give you something like this. Okay, maybe not this awful. And they want you to go backwards and make it one logarithm. And that's really, I think, what we use the most in solving equations. So let's do a couple of those, and I'm done. I think I only have 2 more, maybe. Maybe 3. I don't know. We'll see. It's a surprise to us all. Write as a single logarithm. Sometimes the directions say condense each logarithm, which means put everything back together that you can. If you see addition, you know it can go back as multiplication. If you see subtraction, you got to know that goes back as division. And if you see a number in front, you got to know that you can put that in back as an exponent. And so those are the 3 things we're looking for, and we just want to simplify it. Some of them are going to be pretty easy, and then a couple of them are going to be a little bit more difficult. My advice to you is deal with the exponents before you deal with the changing addition and subtraction. It'll just make your life a lot easier. So when I see this problem, I see subtraction, and I know that can go back to division. But before I do that, I want to deal with that 2 first. What can I do with that 2? It's an exponent, right? We're just going backwards now. We're doing the opposite. So this is the same as log base 3 of u squared minus log base 3 of v. And after you do a few of these, you might do it all in one step, which I'm okay with. But step 1, I'm going to put the exponent back up. And then I can do what with subtraction? Division. And here's the big thing. When you write as a single logarithm, you should only be writing log 1 time. If you write log more than 1 time, you haven't simplified it all the way. So I'm going to write log base 3 of u squared divided by v. And that's it. If you can simplify more, you can. But in this one, u and v, we can't do anything with. And as we get into section 3.5 and solving equations, if we can get 1 logarithm, that makes our life a lot easier. Okay, ready to end on a good one? Oh my goodness. said it was a good one. I didn't say it was easy. You said it was easy. What should I do first? Put the 8 back as an exponent. Deal with your exponents before you start putting things back as one logarithm. So I'm going to put this 8 up here. So I would have log base 2 of the square root of 3x minus 2 to the 8th power. And then all that other stuff stays the same for now. It's like a race over there or something. I don't know. Can I simplify this? Can I simplify the square root to the 8th power? Does that become the 8th root? Let's think about our fractions. How could I rewrite the square root as a fraction exponent? Right, on this one over there, like, let's go back to this to remind ourselves. Oh my gosh, why is this so much thing? When we had the cube root, we wrote it as the 1/3 power, yes? Fractional exponents. So if I have a square root, what fraction is that? 1/2, right? 3x minus 2 to the 1/2 power, that's the same as the square root. And then what do you do when you have an exponent to an exponent? You multiply them.
Wait, where did you get the square root? The 1/2.
The square root was in the original problem.
Oh, okay.
I just changed it from a square root to the 1/2 power, which means I believe this would be the same as 3x minus 2 to the 4th power. Yes? So that's, again, kind of making you go back and think about those exponent rules. Now I'm going to rewrite all this. Log base 2 of 4 over x plus log base 2 of 4. Someone in second hour pointed out, why don't I just evaluate log base 2 of 4? Because I can, like that actually is a number. But we don't want to do that on this problem because the directions doesn't say simplify. The directions say put back as one logarithm. So we don't want to get rid of a logarithm. We want to keep that there. But now I think we could just put stuff back together. What does this mean? Division. What does this mean? Multiply. So I think I could do this all in one step here. I'm going to take log base 2 of this divided by this multiplied by this. And it's going to kind of look like a big mess, but I'm going to write that and then deal with it. So let's see. I'm kind of writing uphill here. Log base 2 of 3x minus 2 to the 4th divided by 4 over x multiplied by 4. So all I did was change subtraction to division and addition to multiplication, and it kind of looks like a big disaster, yes? And we're just going to leave that as our answer and go on. No, don't leave that as our answer and go on. We have to simplify it, right, Tyler? Shut his notebook already. I was saying that's what you would do, but it's not okay to do that. Because it's never okay to leave a fraction in a fraction, right? We talked about this. We had a question on a test. I think it was our chapter 1 test, where everyone left a fraction in a fraction. How do you deal with dividing by a fraction? Multiply by the reciprocal. So this is the same as saying 3x minus 2 to the 4th times the reciprocal of this, which would be x over 4, and then I still have that times 4 out there also. Can I do anything? Fours cancel. Can I multiply this x inside this 3x minus 2 to the fourth? No. Because it's to the fourth power. So you'd have to multiply that 3x minus 2 to the fourth out if you wanted to multiply x in there. So that's a whole lot of work. We don't want to do that. So we're just going to leave our answer like this. I'm going to write log base 2 of x times 3x minus 2 to the fourth. I can't multiply that in there because that's actually 3x minus 2 4 times. You can't just multiply an x in there. Think about order of operations. You got to deal with that exponent first. So the simplifying part, the algebra part, might be the part that gets us the most. The actual properties aren't that bad. But remember, it wouldn't be okay to leave an answer like this. Again, they're not all like that. This is homework 3-4. Should be on your assignment sheet. 3 through 36 multiples of 3, 53, 59 through 62 all.